It's the autumn of 1957, in a small lab in Mountain View, California. 8 young scientists sit in a room, and one by one, they sign their names on a single dollar bill. It is not a contract, it is a pact. Within hours, all 8 will walk into the office of their boss, the man who hired them, the man who just won the Nobel Prize, and quit, together. On the same day, that man will spend the rest of his life calling them traitors. The press will give them a name that sticks for 60 years. The Traitorous Eight. Here's the thing nobody in that room could have known. The company they were about to build, and the company that would spin out of it, would invent the chip that runs the modern world. Every phone, every laptop, every server humming inside every data center on Earth, all of it traces back to 8 men, $1 bill, and a decision to walk away. To understand why 8 men would quit a Nobel laureate, you have to understand the man and the invention that made him famous. His name was William Shockley. In 1947, at Bell Labs in New Jersey, Shockley and 2 colleagues built the first working transistor. It was a tiny sliver of material that could amplify a signal or switch it on and off. It doesn't sound like much, but the transistor would replace the bulky, fragile vacuum tube, and everything electronic that came after, from radios to rockets to computers, would be built from it. In 1956, Shockley shared the Nobel Prize in Physics for it, but Shockley wanted more than a prize. He wanted to build the company that would manufacture transistors and get rich doing it. So he left Bell Labs, moved back to the town he grew up in, Palo Alto, California, and founded Shockley Semiconductor. At the time, there was almost no technology industry in that quiet stretch of orchards south of San Francisco. Shockley was about to plant the seed of one. And to do it, he went looking for the brightest young physicists and engineers in America, and he found them. If you're enjoying this, hit subscribe. We tell the real stories behind the world's greatest builds. Because the men he recruited were extraordinary, that was exactly the problem. The recruits were the best of their generation. Robert Noyce, a charismatic physicist from Iowa, Gordon Moore, a quiet, brilliant chemist, Jean Hoerni, a Swiss theoretician, Eugene Kleiner, Victor Greenwich, Julius Blank, Jay Last, Sheldon Roberts. Young men who had crossed the country for the chance to work with the inventor of the transistor. And then they met the boss. Shockley was a genius. He was also, by nearly every account, a nightmare to work for. He was suspicious of his own staff. When a secretary cut her finger on a pushpin, he became convinced someone had sharpened it deliberately as an act of sabotage and ordered lie detector tests for the whole lab. He posted everyone's salaries on the wall. He recorded phone calls. He praised in public and humiliated in private. Then came the technical break. Shockley grew obsessed with a complicated 4-layer device of his own design and steered the lab away from the simple silicon transistor his young engineers believed was the real future. They thought he was chasing the wrong dream and making their lives miserable while he did it. They tried going over his head. They quietly contacted Shockley's financial backer, Arnold Beckman, and asked him to move Shockley into an advisory role. Beckman wavered, then sided with the Nobel laureate. Now Shockley knew his own people had tried to remove him. The lab became unbearable. For 8 of them, there was only one way out. They would have to leave, all of them, at once. There was a problem. In 1957, you did not just quit your job and start a company. Venture capital as we know it did not exist. Engineers were employees, they worked for someone, and they stayed for decades. The idea that 7 of them could simply leave and find a backer overnight was almost unthinkable. They needed a leader, and they needed one man in particular, Robert Noyce. Noyce was the most respected scientist in the group, the one the others would follow. For weeks he hesitated. Walking out on the inventor of the transistor felt like heresy. Then he agreed, and the moment Noyce was in, the group was real. To seal it, they each signed a single dollar bill, a makeshift founding document, a promise that they were in this together. Then they walked in and resigned. Shockley was stunned. He had handpicked these men, and they had abandoned him in a single coordinated blow. He called them the Traitorous Eight, and the name followed them for the rest of their lives, though over time it curdled from an insult into a badge of honor. But pride doesn't pay for a laboratory. The 8 had their freedom and almost nothing else. No money, no factory, no product, and no company in America was willing to hire 8 men as a single package deal. They had burned the only bridge they had, and they had no idea where the next one would come from. Then, one of the 8, Eugene Kleiner, did something that would change finance forever. He wrote a letter. His father had a contact at a New York investment bank, and Kleiner laid out the situation. A complete team of world-class engineers, ready to build, looking for someone to back them. The letter landed on the desk of a young banker named Arthur Rock. Most people in finance would have thrown it away. You didn't invest in 8 engineers with no company and no product. Rock saw it differently. He believed the people were the asset, that the right team was worth betting on, even with nothing else. It was a radical idea, and it is the founding idea of venture capital. Rock went looking for someone with money and nerve. After dozens of rejections, he found Sherman Fairchild, an inventor and the largest individual shareholder in IBM, a man who loved technology and was willing to gamble. Fairchild agreed to fund the new venture through his company, Fairchild Camera and Instrument. The deal closed. In October of 1957, Fairchild Semiconductor was born. In a rented building in Mountain View, with 8 founders and a single mission. They had to invent a way to manufacture silicon transistors. Cheaper, faster, and more reliably than anyone on Earth had ever done it. They had the money now. What they didn't have was the slightest guarantee it could be done. The early transistors of the 1950s were a mess to manufacture. They were built with delicate wires and exposed surfaces, like tiny 3-dimensional sculptures, and they were fragile. Dust could ruin them. Moisture could kill them. To build a reliable electronic future, someone had to find a way to make transistors that were tough, consistent, and producible by the thousand. At Fairchild, that someone was Hoerni, the quiet Swiss physicist. His idea was deceptively simple. Instead of building the transistor up off the surface of the silicon, he would build it flat, protecting the delicate junctions under a smooth, sealed layer of silicon oxide, like laminating them under glass. He called it the planar process. It sounds like a small refinement. It was a revolution. The planar process made transistors dramatically more reliable because the sensitive parts were sealed away from the world, and it made them printable. You could lay down the pattern with light and chemicals, the way you print a photograph, and you could do it across a whole wafer at once. Suddenly, manufacturing electronic components looked less like sculpting and more like printing money. But the planar process did something even bigger than make better transistors. It opened a door nobody had walked through yet. If you could print one transistor flat on a slab of silicon, sealed, reliable, connected, then why stop at one? Why not print many of them on the same piece of silicon and wire them together? That question was about to change everything. In 1958, 1,000 miles away in Texas, an engineer at Texas Instruments named Jack Kilby had the same dream. Kilby built the first working integrated circuit. Multiple components on one piece of material. It was a genuine breakthrough, but it was also a clumsy thing, with tiny gold wires soldered by hand connecting the parts. It proved the idea could work. It did not show how to build millions of them. Back at Fairchild, Robert Noyce took Hoerni's planar process and saw the final piece. If the transistors were already sealed flat under that smooth oxide layer, you could lay thin lines of metal right on top of the surface to connect them. Printed wiring, no hand soldering at all. The whole circuit, components and connections together, could be manufactured in one flat, repeatable process. This was the integrated circuit that could actually be mass-produced. Kilby is rightly remembered as a co-inventor of the chip. But it was Noyce's silicon, planar version that became the blueprint for the entire industry. The two ideas, Kilby's vision and Noyce's manufacturability, together gave the world the microchip. And the effect on Fairchild was explosive. Orders poured in, first from the military and NASA, who needed small, reliable electronics for missiles and the Apollo program. Fairchild Semiconductor went from 8 men in a rented room to one of the hottest companies in American technology in just a few short years. They had built the impossible. And that was when the trouble started. Here's where it gets interesting. Fairchild Semiconductor was a money machine, but the profits flowed east to the parent company, Fairchild Camera and Instrument in New York. The men in California who were actually inventing the future watched their breakthroughs fund a corporate headquarters 3,000 miles away, while the bosses back east refused to share real ownership with them. And these were not men who liked being told no, so they did the only thing they knew how to do. They left. One by one, Fairchild's best engineers walked out to start their own companies. Hoerni left, Jay Last left, they founded new firms, and the engineers in those firms left to found still more. The defectors became known as the Fairchildren, and the family tree they created is staggering. Dozens of companies trace their roots directly to Fairchild, including a rival you've heard of, founded by another Fairchild alumnus called AMD. This was the moment a stretch of California orchards became Silicon Valley. The defining habit of the place, talented people leaving to start something of their own, again and again, was set right here. And in 1968, the two most important men of all decided it was their turn. Robert Noyce and Gordon Moore, two of the original Traitorous Eight, walked out of the company they had built. They were going to do it one more time. When Robert Noyce and Gordon Moore decided to start their own company, they called the same man who had backed them 11 years earlier, Arthur Rock, by now one of the most respected investors in the country. This time there was no struggle to raise the money. Rock made a few phone calls and pulled together $2.5 million in a single afternoon, mostly on the strength of two names. That is how much Noyce and Moore were worth by reputation alone. They named the company Intel, short for Integrated Electronics, and they brought with them a third man who would become just as important as the founders. His name was Andy Grove, a Hungarian refugee who had fled communism, and he was the operator, the disciplinarian, the one who would actually run the place. Noyce inspired, Moore saw the future, and Grove made the trains run on time. Intel's first product was not the processor it would become famous for. It was memory. In the late 1960s, computer memory was built from tiny magnetic rings strung together by hand. Intel bet it could replace all of that with silicon chips. Faster, smaller, and cheaper. The bet worked. Intel's memory chips were a hit, and the young company grew fast. Then, in 1969, a small Japanese calculator company called Busicom walked in with a contract, and a problem that would accidentally change the world. Busicom wanted Intel to build a set of 12 custom chips for a new line of calculators. It was a big, messy job, a different specialized chip for every function. An Intel engineer named Ted Hoff looked at the request and thought it was backwards. Why design 12 narrow chips that could only ever be calculators? Why not build one general-purpose chip, a tiny, programmable computer on a single sliver of silicon that could be told what to do by software? Instead of wiring the intelligence into the hardware, you would write it in code. It was a profound idea, and it fell to another engineer, Federico Faggin, to actually make it real. Faggin did the brutally hard work of cramming an entire processor onto one chip, and in 1971, Intel released it. They called it the 4004, the Intel 4004. It was the world's first commercial microprocessor, a complete computing brain, smaller than a fingernail, that held as much processing power as the room-sized machines of just a few decades earlier. At first, almost nobody grasped what it was. Intel had built it to power calculators. They even had to buy back the rights from Busicom to sell it freely. But slowly the founders understood. They had not built a better calculator part. They had built a general-purpose engine for thinking, a chip you could program to do almost anything. The entire future of computing had just been compressed onto a single piece of silicon. But the microprocessor was the future. Memory was still Intel's present, and in the early 1980s, that present nearly killed the company. Japanese manufacturers had learned to make memory chips with relentless quality and brutal pricing, and they flooded the market. Intel, the company that invented the silicon memory business, was suddenly losing money on every chip it sold in it. The firm was bleeding cash and morale. Then Andy Grove and Gordon Moore had one of the most famous conversations in business history. Grove asked Moore a simple question. If the board threw them out and brought in a new chief executive, what would that new person do? Moore answered without hesitation. He would get Intel out of the memory business. Grove looked at him and said, "Then why don't we walk out the door, come back in, and do it ourselves?" And that is exactly what they did. Intel abandoned the very business it was founded on, memory, and bet the entire company on microprocessors. It meant layoffs, closed factories, and walking away from its own history. It was wrenching. It was also the decision that saved Intel. Because by then, a much bigger bet had already paid off. When IBM built its first personal computer at the start of the 1980s, it needed a brain. It chose Intel's microprocessor. That single design win put Intel chips inside the machine that would land on hundreds of millions of desks around the world. Once the IBM personal computer took off, every machine that wanted to be compatible with it needed an Intel-style chip. Intel's architecture, the family of designs known as x86, became the standard the entire industry built around. Software was written for it. Competitors had to copy it. With every new generation, the chips got faster, following the steady doubling that Gordon Moore had predicted years earlier, a pattern the world now calls Moore's Law. Then Intel did something no chip company had done before. It advertised to ordinary people. The chip was buried deep inside the machine, where no customer would ever see it, so Intel put a sticker on the outside and ran a marketing campaign built around two words: Intel Inside. It turned an invisible component into a household brand. By the 1990s, Intel was the most valuable semiconductor company on Earth, its processors humming inside the overwhelming majority of the world's personal computers. The company that started with 8 men and a signed dollar bill now sat at the center of the digital age. And almost every part of that story, the planar process, the integrated circuit, the microprocessor, the culture of leaving to build something better, ran straight back to a single room in 1957, and a decision that everyone at the time called a betrayal. Think about what actually happened here. 8 engineers were not trying to invent Silicon Valley. They were just trying to escape a boss they couldn't work for. They signed a dollar bill, walked out the door, and built one company. That company spawned Intel. Intel and its cousins spawned hundreds more. And the simple radical habit they started, that talented people should leave and build their own thing rather than wait for permission, became the operating system of an entire region, and eventually of the global technology industry. There is a map that researchers have drawn of the companies descended from Fairchild Semiconductor. It looks like a family tree with thousands of branches. Nearly every great chip company traces back to those 8 names. William Shockley won the Nobel Prize, and history mostly remembers him as the difficult man the future walked away from. The traitors he cursed built that future instead. Silicon Valley was not founded by a visionary with a master plan. It was built from a walkout, a dollar bill, and 8 people who decided they were better off betting on themselves. If stories like this change how you see what's possible, subscribe. There are more builds to uncover.